Welcome to my new course where I teach you how to manage VMware vCenter and ESXi environments with PowerCLI. In this video, I will explain in less than 4 minutes who this course is for, what you will learn, and why you should learn PowerCLI and PowerShell. You're the ideal participant if you have so far used the graphical user interface to manage VMware vSphere. Now you'd like to automate boring repetitive tasks and therefore save time. Maybe the company you work for, or better said their VMware environment, has grown so rapidly that the administration via the graphical user interface is no longer possible without working overtime. You don't need prior PowerShell skills for this course. However, if you already have some basic knowledge, you can simply go ahead and skip the first couple of videos where we discuss the basics and set up our development environment. After explaining the PowerShell basics, I will show you step by step how to manage VMware vSphere environments with PowerCLI. We start with querying and managing virtual machines and their snapshots, VMware Tools, and hard disks. You will also learn how to remotely interact with the VM's operating system from your local PowerCLI session. This works even if the VM has no network connection. After that, we get to one of the highlights of the course. In particular, when creating VMs, we want to add as many automation elements as possible and therefore save as much time as possible. Then we look at different ways to export data. For instance, we will step by step create this HTML report, which you can automatically send to your inbox every single morning. Alright, but why should you learn PowerCLI and PowerShell now? The nice thing about PowerShell is that it has a very steep learning curve. Once you've understood the basics, the entire world of PowerShell opens up to you. More specifically, once you understand how the PowerCLI module works, for example, it will be very easy for you to use the Active Directory module or any of the other modules. The main advantage of learning PowerShell is that you can save a lot of time by automating recurring tasks. By the way, VMware published a survey last year in which VMware vSphere administrators were asked about their favorite administration tools. Not surprisingly, PowerCLI ranked number 1. If you're still hesitating, I've enabled a free preview for some videos, so you can check if you get along with my teaching style before enrolling in the course. By the way, once you're enrolled, you're always allowed to contact me if you have any questions. So what are you waiting for? I look forward to seeing you in the course. One decision you have to make is which PowerShell version you want to use. First, there is Windows PowerShell, which is based on .NET Framework and therefore only works on Windows. The latest version is Windows PowerShell 5.1, which is pre-installed on Windows client and server operating systems. In 2018, so already a couple of years ago, Microsoft decided to make PowerShell available cross-platform, i.e. also for Linux and macOS. Windows PowerShell is no longer under active development. However, it still receives critical security updates and bug fixes. The only advantage of Windows PowerShell is that it's pre-installed on Windows systems. The PowerCLI module is available for both versions of PowerShell. However, in this course, we will use the newer and more future-proof version of PowerShell. At the time of this recording in June 2022, that's PowerShell 7. But even if version 8 will be released in a few years, as an end user of the PowerCLI module, you won't notice any major differences. That also means if you want to use Windows PowerShell for some reason, you can go ahead and do so. You will notice only minimal to no difference. Also pre-installed on Windows operating systems is the ISE, a development environment for PowerShell. However, ISE is also no longer developed further and only works with Windows PowerShell. Therefore, I recommend you to switch to the free development environment Visual Studio Code. You can download it from code.visualstudio.com/download. Here, you select the appropriate installer for the operating system you're using. I use Windows. After the executable is downloaded, we run it and accept the license agreement. We can leave the installation path and the Start menu folders on default settings. In the next step, there are some checkboxes that are optional. You can set them according to your personal preference. If we set this checkmark and right-click a file in Windows Explorer, we get the option Open with Visual Studio Code. The next checkmark does basically the same, but not when right-clicking files, but directories. If this checkmark is set, Visual Studio Code is set as the default program for all compatible file types. And there's many of them: HTML, CSS, Python, and many more. So think twice if you really want to set this checkbox. With add to path, an environment variable is created. When enabled, we can simply type code into the command prompt or the run window and Visual Studio Code will be started. After the installation, we run Visual Studio Code and get this welcome page. I close it and navigate to the extensions, which you can find in the sidebar. Here, we install the PowerShell extension. When creating PowerShell scripts, it supports us with many things, for example with syntax highlighting. Make sure you install the extension published by Microsoft. After installing the extension, we install PowerShell 7. The best way to do so is via the Microsoft Store. Again, make sure that the app is published by Microsoft. If this doesn't work for you for some reason, you can also download the MSI file by clicking the link below this video. If you use Windows, you can create a new file with the shortcut Ctrl+N. Alternatively, you can click on File and then on New Text File. As the name indicates, we now have a text file, but we want a PowerShell file, of course. So we click on Select a language and type PowerShell. At the bottom, you can see the terminal where the code is executed. Up here, we have the region where we create our source code. By clicking File and then Save As, we can save the source code as a PS1 file. And with File, Open File, we can open an existing file. To make it easier to read for you, I zoom in with the shortcut Ctrl+. Down here, we can find out which version of the PowerShell is currently in use. For me, that is version 7.2, which we've just installed from the Microsoft Store. If you are using version 5.1 here, aka Windows PowerShell, just click on the Show PowerShell Session menu link. I could now switch back to Windows PowerShell, either in the x64 or x86 version. You would see something like Switch to PowerShell Store. By the way, the appearance of this bar changes depending on the Visual Studio Code version and the theme, so don't be confused if it looks a bit different in your case. You might even see the PowerShell version directly in the bar. By the way, PowerShell commands are called commandlets. At least it's pronounced commandlet. It is written cmdlet. Commandlets usually consist of a verb and a noun, which are separated by a dash. Commonly used verbs are get to retrieve information, start to start something, remove to delete something, and new to create something. Together with the noun, you can then often guess what the commandlet does. An example is get service, which displays the services. The commandlet write host simply makes an output on the terminal. With the parameter object, we can specify the text we want to display. With foreground color, we specify the text color. With this button or the F8 key, we can execute the line where the cursor is. Alternatively, you can simply highlight the code you want to execute and then click the execute button as well. It doesn't matter if this is only a part of a line or several lines. There's one more thing I would like to do before we can get started. Let's call the command palette with the F1 key or with Ctrl+Shift+P. Here we type JSON and select Preferences Open Settings JSON. Here we can set our preferred settings. An example of this would be our preferred text size. However, I would like to point out one thing that is set a bit unhelpfully by default, at least when creating PowerShell code. And that is that the list we get when we start typing shows a lot of useless information by default. I'll show you an example in a second. We can turn it off with editor.snippet suggestions none. From now on, only relevant information will be displayed. If the auto-completion with the tab key is not working in your case, you can enable it with editor.tabCompletion on. Please pay attention to the spelling. Multiple entries must be separated with a comma. You can also copy the code below this video. By clicking File, Save, we can save our preferences. In this lesson, I will talk about what modules are in PowerShell and how we can install the VMware PowerCLI module. Depending on the exact version, PowerShell consists of multiple thousand commandlets. We can extend the functionality even further by installing so-called modules. A module is a set of commandlets and functions. Theoretically, we could even create our own module. On the other hand, there are already existing modules for applications such as Microsoft 365, Azure, Group Policy, the Microsoft Exchange Server, and also for VMware products. The module we need for this course is called VMware PowerCLI. We can install it by calling the install module commandlet and passing it the name of the module with the parameter name. Please pay attention to the spelling, i.e. vmware.powercli. If you would run the command as it is, the module would be installed for all users of this computer. For that, you have to start Visual Studio Code with administrative rights. Otherwise, you will get this error message. If you want to install PowerCLI only for the user account that is currently logged in, just specify the parameter scope and set it to current user. Then, the module will be installed in your user directory and does therefore not require admin rights. Now we get a warning asking us if we really want to install the module. Since we know exactly what we are downloading, we confirm with Y for yes. Now we have successfully installed the module. While some of you might have rolled your eyes while reading the headline, I can tell you that PowerShell has a very good help system on board. To exaggerate, you only need to remember two commandlets to master PowerShell. The first one is called get command. If we call it without any parameters, it returns all available commandlets. That's not very helpful. Let's say you want to create a new snapshot with PowerShell, but you don't know what the appropriate commandlet is called. Then you simply run get command and specify the keyword snapshot with the parameter name. However, there are no results because we only search for commandlets where the name is exactly snapshot. Instead, we need to put the wildcard character before and after the keyword. A wildcard is a placeholder, meaning there could be other characters and words in front of and behind our keyword. Now we get every commandlet that includes the word snapshot. On the right side, you can see where the commandlet comes from. Since we are only interested in PowerCLI commandlets, we can limit the search to this module with the parameter module. As you can see here, the PowerCLI doesn't consist of one module, but of several. The good thing is, all of them start with VMware, so we can pass the module parameter VMware, followed by the wildcard character. Now we still have several options to choose from, but since we want to create a snapshot, only the verb new makes sense. Since we want to create a VM snapshot and not a vSAN snapshot, new snapshot is the commandlet we are looking for. Excellent, now we know what the commandlet is called, but we still have no idea how to use it. This is where get help comes into play. Here, we also use the parameter name and provide it with the name of the commandlet, so new snapshot. Now we get a description of what the commandlet does and what compatible parameters there are. So far so good. Later in the course we will dive deeper into the help system. In order to be able to manage VMs, data stores and so on with PowerCLI, we first have to connect to a vCenter or an ESXi host. The commandlet for that is connect vServer. As soon as I type that, a yellow warning appears. It asks us if we want to participate in the VMware Customer Experience Improvement Program and therefore send data to VMware. If we do nothing, the message appears over and over again, which is quite annoying. The good thing is, we also get the command with which we can set our preference. So the commandlet is set PowerCLI configuration. With the parameter scope, we specify if we want to set it for all users on the computer or only for the current user. And with participate in CEIP, we specify if we want to participate in the program, which would be $true, or if we don't want to participate, which is $false. I do not want to participate. The PowerCLI now asks us if we really want to execute the command, which we of course confirm with Y for yes. Okay, back to connect vServer. With the parameter server, we specify the IP address or the DNS name of the ESXi host or vCenter server. If you want to sign in with single sign-on, you can just run the command as it is. If you don't want to use SSO, you can specify the username and the password with the parameters user and password. However, then we have the password in plain text, which we definitely don't want. I will explain later in the course how you can save the password securely. For now, we simply don't specify the two parameters. What happens then is that PowerShell simply asks us for the username and password. The latter is replaced by asterisks. Ideally, you should then be connected directly to the vCenter or ESXi host. Or you also get the message that the SSL connection could not be established. The message is displayed when the certificate is invalid. This could be because the certificate is expired, or it is only issued to the FQDN, but you provided the IP address in the connect command. If this is a test environment like mine and you would like to connect to the vCenter anyway, you can set this preference with the set PowerCLI configuration commandlet. I want this to apply only to my user account. This time we need the parameter invalid certificate action. We set it to ignore, execute the command, and confirm it with yes. By the way, if you want to display the configuration at a later time, you can simply replace the verb set with get. By default, however, not all attributes are displayed here. For example, we can see invalid certificate action, while we don't see participate in CEIP. I will show you how to display all attributes in a later video when I talk about the pipeline. Now the connection was successfully established. For the unlikely case that your vCenter listens to a different port than the standard port, you need to specify it using the parameter port. We can use the disconnect VI server commandlet to end the session. Now, I would have to confirm this again with Y. However, at this point I use Ctrl+C to snap out of this question. A parameter that is very helpful is the confirm parameter. It has a relatively special syntax. It's followed by a colon without blanks and then the variable $false. This way, we tell the PowerCLI that we are sure we want to execute the command and that we don't want to be asked again. If we execute the command now, the session will be ended. This video is all about the get_vm commandlet. Before we get started, we need to connect to an ESXi host or vCenter server using the connect VI server commandlet. You have learned how to do this in the last video. After the connection is established, we simply execute the get_vm command without any parameters. Now we get a list of all virtual machines. Since I don't have too many VMs in my test environment, the output is relatively clear. In productive environments with thousands of VMs, however, the output wouldn't be that helpful. That's why we usually always specify parameters to make our intentions more clear. Now I want to present to you the most helpful parameters. If you're searching for a VM with a specific name, you can use the parameter name. If I execute the command now, I only get this VM. It is very convenient that wildcards are supported, so I can display all VMs starting with SRE for instance. The character we need for that is the asterisk. You can also set the wildcards in the middle or at the beginning of a string. If you use the asterisk as the wildcard character, the placeholder can be indefinitely long. Alternatively, you can use the question mark. It has the length of exactly one character. Instead of the name, you can also query all virtual machines that are located on a specific data store. In this case, I want to display all VMs that are located on data store 1. At this point, a small note about the quotation marks. They are only mandatory if the string consists of multiple words. So if there's no space, like in the previous example, we don't need to put them. We can also query all VMs that are connected to a specific vSwitch. In my case, I want to get all VMs that are connected to vSwitch 0. Now here's a little disclaimer. The course will definitely get more exciting. However, you need to understand the basics first. Another parameter is called location. It accepts multiple objects. You can specify resource pools, vApps, VM hosts, folders, clusters, and data centers. I'm providing my cluster name here. If you don't know the name of your cluster, you can simply find it out with the get_cluster commandlet. As you can see on the basis of get_cluster, the commandlets are always constructed in a way that you can easily guess the name. Another straightforward example for that would be get_folder. Another parameter is called tag. Here I query all virtual machines that have the tag Linux assigned. For this, you obviously need to create tags and assign them to VMs before. Now I'd like to show you a slightly different approach. We use getDataCenter to query all data centers in our vSphere environment. If you have multiple data centers, you can set a filter on the name, just like we did with the commandlet get_vm. Now we store the data center in a variable. Remember, you can easily recognize a variable because it's always introduced with a $sign. I name my variable $myDataCenter. We can output the content of the variable by simply typing its name. The data center is not stored as a string, but as an object. In previous PowerCLI versions, it was oftentimes a problem if you only specified a string. Even if you look at the get VM help today, many parameters want to be provided with an object and not a string. With the current version, it oftentimes doesn't matter if you provide an object or a string. However, we will get to a rare example later where it matters. For now, you should keep in mind that if you see an error message, you might need to provide the commandlet with an object instead of a string. Anyway, then we simply run the getVM command and pass in the variable with the data center object. You may have noticed that the getVM command per default only returns the 4 attributes name, power state, the number of CPU cores, and the memory. But every VM has much more attributes. This is where the pipeline comes into play. First, we query all VMs in our vCenter with getVM. We don't want to display the result on the screen. Instead, we want to send it over the pipeline to the next commandlet, in this case select object. When you have a look at Unix, only text is passed over the pipe, but because PowerShell is an object-oriented language, we transfer objects, which gives us a lot of advantages. With select object, we can select the attributes of an object we want to display. The parameter we need for that is called property. In the first step, we simply put a wildcard character here. Now we get all attributes of all virtual machines that we have passed over the pipeline. As you can see, every VM has way more properties than the 4 we can see by default. Since displaying them as a table would not fit on the screen anymore, PowerShell automatically formats the data as a list. Instead of the wildcard, we can also specify the attributes we want to display. For example, name, folder, and let's say hardware version. When specifying more than one attribute, we have to separate them by a comma. Did you notice that the output fits on the screen as a table again? If you're not sure which attributes exist or what they are called, you could either query them with select object property wildcard, or you could take the command, in this case getVM, and pipe the output to the commandlet getMember. This will list all compatible attributes. Let me just add the attribute nodes here. As I already mentioned, PowerShell automatically formats the output as a table or a list, depending on how much space there is. Sometimes we need to change the format. For example here, the nodes attribute is cut off, so we have a table but we want a list. All we have to do is to replace select object with format list. Excellent, now we have a list and are able to read the full content of the nodes attribute. To format the output manually as a table, we can use the commandlet format table. Another very helpful commandlet is out grid view. As you can see by the error message, it's not compatible with format list or format table. Therefore, we need to change the command back to select object. Out grid view redirects the output to a new window. Here we get a very clear output and even have a full text search. Additionally, we can set filters, for instance on the attribute folder. The filter operators change automatically depending on the attribute. When you work with numbers, for example, filters like greater or equal are available. Now here's the downside. The out grid view commandlet is only available on Windows. As you have seen, one command can consist of multiple pipelines. The commandlets are hereby processed from left to right. Another commandlet that can only be used behind a pipeline is where object. With where object and the parameter filter script, we can set filters. Here's an example. We have some virtual machines, some of which are powered on and some of which are powered off. Now we want to query only the VMs that are powered on. Expressed in a more technical way, we want to query all VMs where the value of the power state attribute is powered on. We can accomplish that with the following syntax. First, we put the whole filter in curly brackets. Then we type the following: $_. $_ is a variable that always contains the current element. So from top to bottom, first the VCLS F7 and so on VM, then the other VCLS VM, then the vCenter, and so on. So far so good. Let's break it down even further and only select the attribute power state of each line. For that, we need the dot notation and then the name of the attribute. The next thing we need to specify is the comparison operator. In this case, we could use both eq for equal or like. I'll explain the most common comparison operators in a moment. Alright, after that, where object expects the attribute value we want to filter by. In this case, powered on. If we execute the command now, we get all VMs that are powered on. As promised, I will now talk about the comparison operators. Most of them are abbreviated. Let's start with eq for equal. With eq, we can check if two objects are equal. The counterpart is ne for not equal. Like is used when we want to compare two strings. The difference to equal is that it supports wildcards, so we could use it, for example, to query all VMs that start with sre. If you're not sure if you have to use like or equal, just try both. In the worst case, you'll get a red error message and you will know that you have to use the other comparison operator. In many cases, like in the example shown, both will work. By the way, like also has an opponent. It's called not like. Now let's talk about the comparison operators we can use to compare numbers. One of them is called LE for lower or equal. Then we have LT for lower than, GE for greater or equal, and finally GT for greater than. Now there's a few more comparison operators, but you will rarely need them. Therefore, we just focus on the few ones that you can use to cover 99% of the tasks. I will put the general where object syntax on the screen. Let's do an exercise. We want to query all VMs that have 2 or more CPU cores. Again, I'd suggest you to pause the video and try to solve the task on your own. Ready? Here's the solution. We can simply use the basic structure from above. One of the few things we have to replace is the name of the attribute. The one that contains the number of CPU cores is called num_cpu. Usually the name you see here is the actual name of the attribute. However, in this case it seems like we're talking about two words and CPU is in plural. That seems a little bit strange to me. So one command that is always right is getMember. So let's see what it says. Okay, so the actual attribute name is num_cpu, without a space and without the s at the end. We can set the filter in two different ways. Either we use the filter operator GT to query every VM that has more than one CPU core. The second way would be to use greater or equal to query every VM that has 2 or more CPU cores. Sorry, that's a typo, it should be 2. It is also possible to set multiple filters. I want both of them to be true, so we concatenate them with the logical operator AND. Then we put round brackets around each conditional statement. With PowerShell 3, a simplified version of where object was introduced. However, I would recommend you to memorize the syntax we've just talked about. This is because it's not possible to link multiple conditional statements with AND or, like we just did. I'll show you the syntax on the screen anyway. As we've already learned, we can use several pipelines in a row. Sometimes it makes sense to use where object and select object together. After we've set the filter with where object, we can use select object to select the attributes we are actually interested in. For example, the name of the VM, the memory in gigabytes, and the creation date. I actually think I made a mistake here because this attribute shouldn't be empty. But it's actually very good that that happens live, so to say, so I can demonstrate you how it would solve the problem. So we take the getVM commandlet and send it over the pipeline to the getMember commandlet. Here we are looking for the whenCreated attribute. Okay, so the problem is the attribute is called createDate and not whenCreated. Perfect, now our query works. Another commandlet that we can only use after a pipeline is sortObject. We could theoretically append it to this line, but I would like to make a new query so the line of code doesn't get too long and confusing. As you can probably tell by the name, we can use sortObject to sort objects. With the parameter property, we can specify the attribute we want to sort the output by. In this example, I would say the create date could be useful.
You've probably recognized that I didn't specify the parameter's name, which is property in this case. If you have a look at the help system, you see that the parameter is in position 0, meaning the first thing we specify after the name of the commandlet. So instead of specifying the name of the parameter, we can just put its value, like I did here. However, I would not recommend you to use this method, because it makes the script more complicated to understand if you look at it at a later point in time, or if somebody else is looking at it. I just wanted to show you that this is possible.
By default, the sorting order is ascending. If you want to sort the object in descending order, you can do so with the parameter descending. Of course, the whole thing does not only work with dates, but also with normal numbers, for example. Or even with normal words, where the sorting is done alphabetically. In this example, backwards from C to A, because we've still specified the descending parameter. Let's talk about starting and stopping virtual machines with PowerCLI. First, we query a VM with the standard get VM command. As you can see, the VM is powered off. Now we need a pipeline and the start VM commandlet. That's all. Of course, we could now open the vCenter web client in a browser window and then open the VM console from there. However, we can also open the console much faster from the PowerCLI session. Again, we need get VM and then send the output over the pipeline to the open VM console window commandlet. As we can see, the VM is already powered on. Alright, let's move on to the restart. The command is called restart VM. We could simply use the same structure as above. However, I want to show you another approach. In particular, we use the commandlet restart VM and the parameter VM to provide the VM name. Now pay attention to the console on the right side. What I want to point out is that it's definitely not a clean restart. Instead, it's like pressing the reset button on a physical server. And that's definitely not what we want to do. Since we will be restarting and stopping the VM more often, I'll just save the name in a variable so I don't have to type it every time. The better alternative is the commandlet restart VM guest. Here, a clean restart is performed. For the commandlet to work, it is necessary that the VMware tools are installed on the guest operating system. As we can see, the services are now terminated properly before the restart. There are also two commands for shutting down VMs. The better commandlet is shutdown VM guest. Here, the services are also stopped properly. Identical to restart VM guest, the VMware tools must be installed on the VM. The other shutdown commandlet is stop VM. If the VM cannot be switched off, you can additionally specify the kill parameter. Here, the VM is literally killed by stopping the services on the ESXi host. So it's comparable to pulling the power plug on a physical server. If you don't like to confirm the execution of every commandlet, just specify the confirm switch and set it to $false. Here you can see an overview of all start, restart and shutdown commandlets. By the way, in the vCenter web client there's a window displaying the recent tasks. The PowerCLI equivalent is called getTask. This video is all about managing snapshots with PowerShell. First, we look at how to create snapshots. For that, we query a virtual machine with getVM. Because I want to create a snapshot of 2 VMs, I use the wildcard character to do so. Then, we send the VMs over the pipeline to the commandlet new snapshot. Here, we give it a name and a description. In my case, the output is a bit weird. But don't get confused if something like that happens to you. As long as there is no red alert, everything is fine. Again, if you don't know what parameters there are, just run get help. Let's say here we find the parameter memory interesting. To learn more about it, we use the parameter. Now we get relevant information about the memory parameter. So if we specify it, the memory of the virtual machine will be included in the snapshot. A requirement is that the virtual machine is powered on. As you can see here, memory is a switch parameter. That means we only specify the parameter, but we don't pass a value. Another parameter that caught my attention is quiesce. Assuming we have no idea what it does, we can just run the get help command again. For quiesce, the VM must also be powered on. Additionally, VMware Tools must be installed on the guest OS. If the parameter is specified, VMware tries to bring the system into a state that is suitable for a snapshot. Be aware that it's also a switch parameter. Now let's query all snapshots in this vCenter environment. For that, we use getVM again, but this time without any parameters as we want to query all VMs. Then we send the VMs over the pipeline to the getSnapshot commandlet. By default, we get the name, the description, and the power state. Let's use getMember to list all attributes that snapshots have. Relevant to me are the name of the snapshot, the creation date, if the snapshot has child objects, and what size it has. So I use SelectObject to select those attributes. I'd like to view the results without grid view. By the way, commandlets like SelectObject, WhereObject, SortObject, OutGridView, and so on are not PowerCLI specific, but work in the whole PowerShell world. I forgot, I also want to include the description. Assuming we want to remove a snapshot, we can use the following method. First, we query the VM. Then, after a pipeline, we query the snapshot we want to remove. As you can see, the snapshot also has children. I want to delete all of them, so I specify the remove children parameter. Since the command doesn't return any output, we just run the getSnapshot command again. Now we get an error message because we just deleted the snapshot. This means that the remove snapshot command worked. Next we want to find and delete all snapshots. For that we need a date. Of course we store it in a variable. A very helpful commandlet when it comes to dates is getDate. By default it returns the current date. However, we want to find old snapshots, so we need a date from the past. There are two ways to do so. One of them is to use the parameters day, month, hour, minute, and so on. For example, if we specify only the parameter day, the year, month, and so on will be taken from today's date. As you can see, the day has changed, because I specified the parameter day. But because we don't want to change the date in the PowerShell code every time, the other method is better in this case. So we tell the command that we want to get the date from, let's say 3 days ago. The 3 days are then always calculated from the time of the script execution. Therefore, we don't need to change the code anymore, no matter if we run the script today or in 2 years. The corresponding method is called addDays. First, we put the original commandlet in round brackets. Then we can call the method with a dot, followed by the method name. This method expects only one parameter, namely the number of days we want to add. Since we don't want to travel into the future, we put a minus in front of it. Now 3 days are subtracted from today's date. With getVM and getSnapshot, we query all snapshots in our environment. With WhereObject, we filter out only the snapshots where the creation date is older than the value in the timestamp variable. To check if our query worked, we should also select the value of the created attribute. Also helpful, at least in my opinion, is the size of the snapshot in gigabytes. Now we want to delete the snapshot, so we send it over the pipeline to the remove snapshot commandlet. That's an error I've made on purpose. When we remove the select object part, the command works. But why is that? To make it easier to understand for you, I've copied and pasted the two commands next to each other. We sent both of them over the pipeline to the commandlet getMember. This does not only return all the compatible properties and methods, but also the object type. As you can see, we have two different types. This one starts with VMware, and this one with selected. Unfortunately, the remove snapshot command is only compatible with this one. The object type that gets created by using select object can't be converted to the type the commandlet accepts. That's by the way what the error message says. Alternatively, you can simply use the method displayed on the screen. Let's have a look at reverting VMs to a specific snapshot. For that, we first query the snapshot and store it in a variable. If your VM has multiple snapshots, you need to select one of them with the parameter name. Then we need the commandlet setVM. We provide it with the VM and the snapshot. That's it. Now the VM is reverted to the state at the time of the snapshot creation. In this video, you will learn about two very helpful commandlets. With one of them, we can copy files into a virtual machine. With the other one, we can execute batch, bash, or PowerShell code inside a VM. Both is possible with a single line of PowerCLI code. It saves us a lot of time because we don't have to connect to the VMs through the VMware console anymore. Another cool thing is that since we are connected to the ESXi host or vCenter, the virtual machine doesn't even need a network connection. For both commands, we need to authenticate to the guest OS. The best way to do so is to create a variable. I'll just call mine $guest credentials. To create a credential object, we can use the commandlet getCredential. It prompts for the username and the password and stores them in the variable. It doesn't matter if you specify a domain user or a local user. At the end of this video, I will give you a short overview of all requirements, just in case something doesn't work for you. Of course, we need a file that we can transfer to a VM. This can be an executable or an ISO file, for instance. In my case, I simply create a text file with PowerShell. One way to do so would be to pipe a string into the commandlet out file. With the parameter file path, we specify the location. Theoretically, we could now use the File Explorer to check if the file was created. Since this is a PowerShell course, we use PowerShell, of course. The appropriate commandlet for that is getChildItem. Here, we provide the path to the file we've just created. Now we know that the file is there. To be completely on the safe side, we can query the file content with getContent. Perfect. As I said, you can use any file. The commands outFile, getChildItem and getContent were only a short excursion into the world of PowerShell. Let's talk about the actual commandlet. It's called copy VM_guest_file. With the parameter source, we specify the path to the file we want to copy. With destination, we specify in which directory we want to save the file on the guest OS. Of course, the commandlet also expects the name of the virtual machine we want to copy the file to. Then there's the parameter local to guest. It indicates that the file is copied from our local system to the guest operating system of the VM. Alternatively, we can use the parameter guest to local. In this case, the file would be searched on the VM and copied to the local computer. Of course, we can only use one of the two parameters at the same time. Finally, we need the credentials we stored in the $guest credential variable. Then we execute the command. As you can tell by the red error message, I forgot to connect to a vCenter server. In general, I can recommend you to not get nervous or give up in case you see an error message. In most cases, by reading the message, you can easily figure out what the problem is. Another common reason for an error message at this point is typing mistakes in the username or password. Excellent. As you can see, after I established a connection to the vCenter, copying the test file was successful. Let's talk about the invoke VM script commandlet. We can use it to execute remote commands on VMs. The parameters with which we can specify the VM name and the credentials are the same. Additionally, we use the parameter script text to specify the command we want to execute. Then we have to specify the type of script. We can choose between PowerShell, Batch, and Bash. As we just learned, we can display the file structure of a directory with getChildItem. The output of the commandlet is made directly into our PowerShell console. Here we can see that the file we copied with copy_VM_guest file is indeed there. As a second example, I'll just run the good old ipconfig command. In this case, we also have to change the script type. As you can see, the command worked. By the way, the command is also compatible with Linux. As an example, I run the disk-free command on an Ubuntu server. Of course, we have to change the script type to Bash. I actually forgot to mention that copy_VM_guest file also supports wildcards, so we could copy all files that are for example located in C10 PowerCLI. Back to the invoke VM script commandlet. You will probably sooner or later run into the following problem. By default, you can only pass single-line commands to the script text parameter. So what if you want to execute more complex multi-line scripts? For that, we first create a variable and store the script in it by using a hash table. Then we pass the variable to the existing invoke VM script command. I've already prepared the script in a separate PS1 file. First, we make an output to the console with the write host commandlet. The test net connection command is the PowerShell equivalent to the ping command. So in this case, we check if we can reach the gateway. Then we output the text trying to disable the network adapter. With getNetAdapter, I then query all network adapters, send them over the pipeline, and disable them with disableNetAdapter. Since I don't want to confirm this, I specify confirm $false. By default, the commandlet has no output, so we force output with the verbose parameter. After that, we execute the test net connection command and try to reach the gateway again. You will understand why I do that in a second. Before, we copy the code into the myCode variable. Alright, time to run our script. This might take around 30 seconds by the way. At first, the ping from the VM to the gateway is successful. Then we disable the network adapter. Here we also see the output of verbose, which we wouldn't see without specifying the parameter. With a disabled network adapter, we obviously can't reach the gateway. That's why the second ping failed. But the interesting thing is, and that's why I chose this example, is that the two commandlets invoke VM script and copy VM guest file work, even without an active network connection of the VM. In case the two commands did not work for you, I'll put the requirements on the screen, so you can check if you met them.
In this video, you will learn how to manage virtual disks with PowerCLI.
We start again by querying a virtual machine. Then we send the VM over the pipeline to the get hard disk commandlet.
By that, we display all virtual hard disks of this VM.
The VM I queried has only one virtual hard disk. Again, we don't see all attributes by default. Therefore, we simply pipe the output into the commandlet getMember. Now we have a list of all available attributes. With select object, we select the attributes that are relevant. For now, I'm interested in the name, the capacity in gigabytes, the file name, and the disk type. The file name attribute also displays the data store on which the vdisk is located. As a reminder, we can query data stores with get data store. Next, we want to increase the capacity of the disk we just queried. If your VM has multiple disks, you need to select the disk you want to increase using the parameter name. Then we send the disk over the pipeline to the set hard disk commandlet. Here we specify the new size with the parameter capacity GB. I want to increase the disk from 32 to 34 GB. Additionally, I specify the confirm switch and set it to $false. When increasing a disk in the vCenter web client, we also need to increase it on the operating system level. The same step is necessary when using PowerCLI. Since this is a Windows server, we could use the built-in disk management. However, the good thing is that we can also automate this task and therefore save a lot of time by using PowerShell. For that, we need the knowledge from the last video. If you haven't seen that video yet, I advise you to watch it now. I'd like to prepare the script on the VM. With the commandlet getPartitionSupportedSize, we can query the maximal possible size of the partition. However, we also get another attribute, so we use selectObject to only query the attribute size max. The problem with the property parameter in this case is that it returns not only the attribute value, but also the name of the attribute and this dashed line in between. However, we only want to have the attribute value. That's why we use the parameter expand property instead. It returns only the attribute value. To make the difference between the two parameters more clear, I'll show you the two parameters in direct comparison on the screen. Alright, we can already insert this line of code into the script. Let's see what happens when we execute it. As you can see, we get the plain attribute value, without the caption and without the dashed line. Now we need a second line of code. With resize partition, we can actually increase the size of the partition. The size parameter expects the new size, so the value we just queried. As you can see, the disk was expanded successfully. Because we have multiple lines, we need to use the special hash table syntax from the last video again. Alright, time to add some automation elements. Of course, we don't want to manually copy and paste the attribute value to the resize partition commandlet. Instead, we simply store the number in a variable. Now we create a few more variables. The variable $diskName should contain the name of the disk we want to expand. The variable VMName contains the VM name, of course. I want to design the script in a way that we only have to specify by how many gigabytes we want to extend the disk. To make that work, we first query the current capacity with getHardDisk. With the parameters VM and name, we provide details about the vdisk. We provide details about the vdisk. However, we don't want an object here. Instead, we only want the current capacity in gigabytes. So we use selectObject in combination with expand property again. The variable increaseBy specifies by how many gigabytes the vdisk should be expanded. Then we need a variable that contains the new size. That's very easy. It's simply this variable plus this one. So in this case, 34 plus 2. Remember what we did at the beginning of this lesson when we used getHardDisk in combination with setHardDisk? Now we need the same structure to expand the disk on the VMware side. I'll just run this part for now. First, of course, we are asked for credentials. As you can see, this has worked perfectly so far. The hard disk has a new capacity of 36 GB instead of 34. Now we execute the invoke vmscript command, which extends the partition to the maximum available size on the Windows side. Since we don't get any output or feedback by default, we add the PowerShell command getPartition. Now we can see that the partition was extended to 36 GB. In the last video, you learned how to query virtual hard disks and extend their capacity. We used the commandlets getHardDisk and setHardDisk. This video is all about the new hard disk command, so we're going to create new virtual hard disks. Like with the set command, we specify the desired capacity with the capacity GB parameter. With the persistence parameter, we set the persistence mode, for example persistent or non-persistent. But be aware that non-persistent disks are deleted when the VM is shut down. With the data store parameter, we specify the data store on which we want to store the VMDK file. Additionally, we have to specify the VM we want to add the disk to. I therefore query the VM with getVM and send it over the pipeline. By the way, if you're wondering what this yellow warning means, it informs us that the version property is deprecated and might therefore stop working in a future version of PowerCLI. Instead, we should use the property hardware version. So we should use this instead of that. In this case, it doesn't affect us at all. Theoretically, we could even disable the warnings with the help of set PowerCLI configuration. The appropriate parameter is called display deprecation warnings. But I personally think it's good to get the warnings. Imagine you use one of those deprecated properties in your script. Then you would be happy to get the warning. Anyway, back to new hard disk. We've created a new disk and the VM's guest operating system can see it. However, we still need to perform tasks like the initialization. That's another excellent use case for invoke vmscript. The procedure is of course different for each operating system family. I use a Windows server as an example.
I won't explain the invoke vmscript code again, so if you haven't seen the video, I'd suggest you to go back and watch it now.
First, we need the PowerShell commandlet getDisk, which lists all hard disks.
Here's the code from the invoke vmscript video.
Oh, here I forgot to specify the VM name. Another very good example where the error message turns out to be very helpful. Then we need to identify the new partition. We can easily recognize it because the partition style is set to raw. By the time, you're probably already aware that I'm a huge fan of automation. That's why I use whereObject to automatically select the disk where the partition style is set to raw. Here, it looks like the partition style property contains a space. Let's verify this with the getMember commandlet. Here, we can see that the attribute name does not contain a space. Excellent. Now the PowerShell automatically selects the disk where the partition style is raw. Let's send the disk over the pipeline again. By the way, if a command is too long for one line, you can use this little backtick character to continue the command in the next line. I'll put a picture on the screen where you can find the position of the character on QWERTY and on QWERTY keyboards. Then we initialize it as a GPT partition. Next, we send the output over the pipeline again. The problem is, initialize disk doesn't return any objects by default, but since we want to send the output over the pipeline again, we specify the parameter pass-through. This causes the commandlet to return the newly initialized disk as an object, which can be sent over the pipeline. By using new partition, we create a new partition. We want to use the entire size that is available on the disk, and we also want to assign a drive letter. Then it's time to send the result over the pipeline one last time. Here we use format volume to format the volume as an NTFS file system. Additionally, we give it a name with the parameter new file system label. Time to execute the script. Let's check if it worked. In Windows Explorer, we see that the assignment of the drive letter and label worked. The size is also correct. Then we open the disk management. Here we see that the disk is online, that the GPT partition style was used, and that we have an NTFS formatted file system, so everything has worked out fine. Let's move on to a very exciting commandlet, namely new VM. Creating VMs the traditional way is a very time-consuming task. That's why we will dive very deep to achieve the maximum degree of automation. But first, we start with the basics. For that, we create two variables. In the first one, we save the name the VM should get. The second one contains the ESXi host on which we want to run the VM. Ideally as an object, so not just as a string as we did with the VM name. Instead, we query the host with get_vmhost. If you have a cluster, I will show you how you can specify it in a few minutes. Let's get to the new VM command. Here we pass the variable with the name to the name parameter and the variable with the VM host to the VM host parameter. This is the minimum configuration for new VM. We can now query the machine we just created with get_vm. The problem is that the VM has lots of standard values, e.g. 1 CPU core and 250 MB of RAM. Additionally, we would have to install the operating system manually, but at least you've got a feeling for how the new VM commandlet works. Like I said, the VM we created is more or less useless, so we delete it with the commandlet remove VM. I will put a screenshot on the screen where you can see how the deletion of VMs works via the web client. In particular, we have two options here, remove from inventory and delete from disk. If we would execute the command as it is, we would remove the VM from the inventory, meaning the VM would no longer be visible in the VM overview, but would still consume space on the data store. So the better option in this case is using delete from disk. To do so in PowerCLI, we need to specify the delete permanently parameter. By the way, if you ever end up in a situation where you want to execute a commandlet, but you're not 100% sure if you're doing the right thing, you can specify the parameter whatif. It is compatible with many commandlets and simply simulates the execution and returns what would have happened if you had executed the command. After deleting the VM, I simply run the get_vm command again. Now we get an error saying that there is no VM with the name we specified. That in turn means that the deletion was successful. The next step is to add more parameters. For example, we can specify the network. I store it in the variable $network. If you have a cluster, you can query it with get cluster. Again, as a reminder, with get help, we can find out about compatible parameters. If we add the parameter, we get more information about the parameter we specified. That was a lot of parameters in one sentence. I want to get more information about the parameter network name. Here we get an explanation of what the parameter does. In addition, we can see the data type that the parameter expects, in this case a normal string. The parameter vmhost, on the other hand, wants to be provided with a vmhost object. That's why we queried it with get vmhost. This way we have an object. The data store parameter also expects an object. Location as well. Since we specify the folder with the location parameter, I name the variable $folder. I want my VM to end up in the folder discovered virtual machine. Here we get the object with the commandlet getFolder. As the data store, I want to use my data store 3. We can simply store the number of CPU cores, the memory, and the disk capacity as a number. As we will provide new VM with many parameters, I suggest you to use the backtick character to move each parameter to a new line. The attribute values are the variables we just created, so $vmhost for the vmhost parameter, $network for the network name, and so on. Theoretically, you could leave out the vmhost parameter when specifying the cluster. Since DRS is not activated in my cluster, I also specify the vmhost parameter here. Then we are ready to run the script. And again, we get an error message: invalid VM processor count. Oh, I'm trying to assign more CPU cores than I have available in my test environment. That's why the error appears. So let's just set the number down to 4 CPU cores. Excellent, now the VM creation works. What we can't see at the first glance is if the VM was added to the folder. The folder object is still stored in the variable $folder. So we send it over the pipeline and execute the get_vm command here. Now we get all VMs that are in that folder. Here we see the VM we've just created. Then we remove the VM again. Most of you have probably already used templates for rolling out VMs. If not, you should definitely do a research on what templates are and how you can use them to your advantage. With getTemplate, we can query our existing templates. Here we need to insert the getTemplate commandlet because we want to get a template object instead of a string. When running the new VM command, we expect the VM to be created like before, with the difference that the template is used. Instead, we get this error message: The important part is, one or more parameters issued cannot be used together. I chose this example intentionally. To be able to understand the message, we call the new VM help again. In this case, we are interested in the syntax. As you can see, we have several sections here. We can either use this syntax, or this one, and so on. However, I think the online version of the help is better in this case. Therefore, we add the parameter online to the get help commandlet. This opens our standard browser, where we can also see the syntax. In the online view, there's a separate tab for each syntax. In the first 4 tabs, we don't find the parameter template. We can only find it in the last one. Parameters like location, network name, VM host, and so on are also listed here. What is missing are the parameters num_cpu, memory GB, and disk GB. This is due to the fact that these properties are simply taken over from the template, i.e. if the template has for example 50 GB of disk space, the new VM will also get 50 GB. So we have to remove the 3 parameters. If you want to have 70 GB of disk space for example, we can use the following trick. After executing the new VM command, we execute the set VM commandlet and provide it with the number of CPU cores and RAM we want to have. I also want that the cores are not distributed over multiple sockets, so set the cores per socket parameter to the same value as num_cpu. To make it more clear, I'll put a screenshot of the web client on the screen. You have already learned how to use getVM and set hard disk to increase the size of the disk. If you haven't seen the corresponding video yet, I recommend you to do so. That was actually way too quick, I didn't even see a progress bar. Let's run getVM to check if the VM was created. As I suspected, the VM hasn't been created. Oh, I found the error. Do you see it too? I put a backtick character in the last line, but we should only set them if the command actually continues in the next line. By the way, this is the progress bar I was talking about. Let's execute the setvm commandlet. And we get another error. Value cannot be found for the mandatory parameter VM. Oops, one time is enough. Do you remember when I said that 99% of parameters accept both objects and strings? setvm is one of the exceptions. It only takes an object for the VM parameter. So we either send the output of getVM over the pipeline, or alternatively store the getVM output in a variable and pass it to the VM parameter of setvm. To be 100% sure, we can query the VMs with getVM. With select object property wildcard, I query all properties. Let's check if you set everything correctly. Pretending you would normally fill the nodes field, you would add it to the commandlet set or new VM as an additional parameter. Afterwards, we start the VM with the start VM commandlet.
Before that, we should actually extend the disk.
I also open the console with OpenVM console window. These were the basics of the new VM commandlet. I recommend you to play around with it and add some more parameters that you would usually use in your environment. In the next couple of videos, we will dive deeper to achieve the maximum degree of automation. This video is all about creating multiple VMs at once. We use an Excel file as the data source. As the column headers, we put some properties we want to set. For example, the name of the VM, the folder we want to store it in, the number of CPU cores, and the memory in gigabytes. Now I fill the table with data. I want to create these 4 VMs. 3 of them should end up in the security service folder, and 1, specifically the SRV SQL 3, should end up in the database service folder. Then I specify the number of CPU cores and RAM. Of course, we could also create more than 4 VMs using this method. Also, you could add more parameters as columns. In my case, I only added those properties because they differ from VM to VM. We will set the remaining ones in the PowerShell script later, but you could also set them here, it really doesn't matter. Anyway, now we save the file as a comma-separated value file, short CSV. In most languages, using the UTF-8 encoding works the best. It also supports special characters like there are in the German or the Swedish language, for example. Whether you create the file with Microsoft Excel or with a free alternative doesn't matter. The important thing is that you have a comma-separated file, as you can see here. To import a CSV file into PowerShell, you need the commandlet import CSV. 3 parameters are important here. First, there's the parameter path, which specifies the path to the CSV file. Then we have the delimiter. This could be a comma, or like in my case a semicolon. If you don't know which delimiter you use, simply open the file with a text editor, like I just did. The third important parameter is encoding. In this case, we should also specify UTF-8 as we did when creating the file. Theoretically, if you're not sure or you just leave out the parameter, you will see if the formatting is correct. If it's not, you either can't read anything or specific characters are replaced with a question mark, for instance. Because we have to access the CSV file several times later in the script, we import it into a variable, e.g. in $VMs. To go through the CSV line by line, we need a for each loop. To create one without remembering the syntax, we can use so-called snippets. First, we open the command palette with the F1 key or the key combination Ctrl-Shift-P. Here, we search for snippet and select Insert Snippet. Now we get a list of all available snippets, for example the if statement, but also the for each loop. By selecting it, the syntax is inserted at the cursor position. Next, we change the variable names. The second variable is $VMs, so the variable that contains the data from the CSV file. For the first variable, the name doesn't matter. Personally, I always use the name of the second one, but in singular. In a moment, you will understand why. I then move the new VM code between the curly braces of the for each loop. Before we get to the functionality of for each, we need a separate variable for each attribute from the CSV file, meaning for the name, the folder, the number of CPU cores, and for the memory. Let's talk about how the for each loop works. We have our variable $VMs. You can see the content on the screen here. With for each, we go through the variable line by line. The variable $VM always contains the current object, meaning the current line. So the first time we go through the loop, $VM is this line, the second time this one, the third time this one, and so on. The question now is, how do we get the individual attribute values? For instance, how do we select only the name in the first run? For that, we need to use the so-called dot notation, so $VM.name. In the first run, it would be srv_wsus1, and the second run srv_wsus2, and so on. The same is true for $VM.folder, num_cpu, and RAM. As you can see, the VMs are now getting created line by line. Because we have 4 VMs, the code between the braces will be executed 4 times. Let's see if the assignment to the folder worked. That looks good already. The same goes for this folder. I've already prepared something here. This video is about creating multiple similar VMs. As an example, let's just assume that there's a Python seminar in your company. Therefore, you have to deploy 12 VMs. Theoretically, the method with the CSV file would also work here. However, I would like to show you another kind of loop. In particular, the for loop. Again, there's a snippet for that, so we don't have to remember the syntax. The head of the for loop is divided into 3 parts. The first part specifies the start value of the variable $I. I want the first VM to be called srv Python training1, so we set the variable $I to 1. In the second part, we specify under which conditions the code between the braces should be executed. We want to have the numbers from 1 to 12, so we specify that the loop is executed as long as the value of $I is less than or equal to 12. For that, we use the comparison operator LE for lower or equal. So when $I is 12, the loop will be executed for the last time. The third part in the head specifies what happens after each run of the loop. We want the value of $I to be incremented by 1 each time. We could specify this with $I equal $I plus 1. Alternatively, there is a shorter way to write it. It's simply $I plus plus. In summary, the start value is 1. We increment the variable by 1 after every single execution of the loop. And we run the loop as long as the variable $I is less than or equal to 12. Let's see how it looks like in action. To test if the loop works, we comment out the new VM part. By the way, we can set multi-line comments with this syntax. The comment starts with the less than sign and then the hash, and ends with the hash and the greater than sign. If we execute the for loop now, the part we've just commented out will be ignored. To see if the loop works, we output the content of the VM name variable on each loop cycle. Perfect, it generated all VM names in the way we wanted. Now that we know the loop works, we simply remove the comment so that the virtual machines are created. In the first run of the loop, the VM name is srv Python training1, because the variable $I is 1 and the name is concatenated from this string and the variable, and then stored in this variable. Then we pass the variable to the new VM commandlet. As we can see in the web client, or by running the get VM command, the rollout of the VMs was successful. Welcome to the final new VM video. In this one, you will learn how to automatically select the data store that contains the most free space. We will also talk about OS customization. Once this is set up, it's possible to roll out VMs within just a few mouse clicks. And by roll out, I also mean things like joining a domain, activating Windows, performing a sysprep, setting the IP settings, and so on. Let's start with the preparation. For that, we log into the vSphere web client. Here, we navigate to policies and profiles and then to VM customization specifications. I have already created one here, but we'll of course create another one together. So we click on New and assign a name. I like to use the operating system name, i.e. Windows Server 2022. Next, we could set a description and choose a vCenter. Then, we need to choose between Windows and Linux operating systems. Most features are only available on Windows. Finally, we can select if the VMs we want to create should get new, unique SIDs. If you use Windows and you don't set the checkmark, the new VMs will get the same SID as the template from which the VM is created. In domain or workgroup environments, it will most likely cause problems if several VMs have the same SID, so I strongly advise you to check the boxes in these cases. Here you can specify registration information. Firstly, the name of the owner of the VM, and secondly, the company name. This step is about the computer name. We have several options in this case. The only one that makes sense in our case is the first one. What that means in particular is, we want VMware to go ahead and simply take the VM name and also use it as the server name, meaning the name on the operating system level. And by VM name, I mean the name we specify when creating a new VM in vCenter. So we don't have to do anything, and the computer name will automatically be changed to the VM name. Here you can enter your license key and license information. Then we can set the password of the local administrator. Also, we can specify if the local admin should log in automatically for a certain number of logins. I personally like to set the value to 2. You will see in a moment what it looks like in practice. Here we should select our time zone. The commands to run once page is not relevant for us, so we simply skip it. Next, we have the network settings. If you want to use the default settings and therefore also DHCP, you can leave the pre-selection as it is. Theoretically, we could select the second point and remove, add and edit network adapters here. In the edit mode, we could also set a static IP address, subnet mask, gateway, DNS servers, and so on. However, we don't want to roll out every VM with the same IP address. So no matter what you want to do, select the first item here. Later, when rolling out the VM with PowerCLI, we query the network adapter and assign it a static IP address there. Of course, only if you want to. If you want to use DHCP, that's fine too, you don't have to do anything. But first, let's have a look at the next page. Here, we can choose if you want to join the VMs to a domain or work group. For the domain join, you need an account that has the appropriate permissions. Afterwards, we get this overview, and with a click on Finish, we can finally create the customization specification. Now we dive into my favorite part, the PowerCLI part. We need our basic structure with the variables and the new VM command to which we pass the variables. By the way, for the OS customization to work, the VMware tools have to be installed on the template. I would recommend you to do so anyway. In my case, I want to use a static IP address instead of DHCP. Therefore, I create separate variables for the IP address, the subnet mask, and the gateway. We do the same for the DNS servers. Then, we create a variable in which we store the OS customization specification we just created. The commandlet for that is called getOSCustomizationSpec. If you don't remember the name of your customization spec, you can simply call the commandlet without any parameters. We also specify the data store where the VM should be stored. This time I will show you how you can automatically choose the data store with the most free space. First, we send the data stores over the pipeline. Here, we sort the data stores by free space using sort object. And now they are sorted, but we still have all 4 data stores to choose from. Therefore, we send them over the pipeline again. You already know the commandlet select object, but so far we've only used the 2 parameters property and expand property. There's one more helpful parameter. It is called first and selects the number of object we specify. In this case, we only want 1 data store, so we set the value to 1. Since we sorted the data stores in descending order, we always get the data store that has the most free space. Let me show you another example. We have 2 types of data stores in this example. One with the word test in the name and the other one with prod for productive in the name. Let's say we are only interested in productive data stores. So we set a filter with the where object commandlet. Because the name of all data stores ends with prod, I don't have to set a wildcard afterwards. The result can be piped to sort object and then to select object like we did before. Next, we create a new VM customization specification with PowerShell. With the parameter OS customization spec, we pass the customization spec, which we created earlier in the vCenter web client and just saved in the variable $existing spec. This copies all settings from the old to the new one. By the way, you only have to do this step if you want to set a static IP address. With the parameter name, we assign a new name. I usually use the word temp and then the VM name, which is already stored in the variable $name. Then we set the type to non-persistent. This ensures that the customization spec won't be stored on the server, but in the local memory of the current PowerCLI session. As soon as the session ends, the temporary object gets deleted. Next, we send the whole thing over the pipeline, where we first query the network configuration with get OS customization NIC mapping. After another pipeline, we then adjust it. In particular, we set the IP mode to use static IP. Then, we specify the IP address with the parameter IP address. The same goes for the subnet mask and the default gateway. If you have more than one DNS server, you can use this syntax. The parameter position indicates the position of the network interface card. Because we only have one, the position is 1. So to summarize, the OS customization spec that we created earlier with the vCenter web client contains the information on how we want to customize the guest operating system. So for instance, which local admin password we want to set, which Windows license key we want to use, and so on. We have also specified that we want to use DHCP. But now we want to use a static IP. So we copy the existing OS customization specification and pass our desired network configuration with set OS customization NIC mapping. We then use get OS customization spec to query the newly created customization spec and store it in a variable as an object. If you want to check the IP settings again, you can send the new customization spec over the pipeline to the command at get OS customization NIC mapping. Now we have to pass the variables to the new VM commandlet again. Among others, the OS customization spec parameter. Here we specify the temporary spec with the static IP address. If you want to use a DHCP address instead, you just have to pass the variable $existing spec, which we defined above. Then we can execute the script and the VM will be created. Next, we query the VM's network adapter with get network adapter. With set network adapter, we can configure it to connect automatically at startup. Here you can see what the corresponding setting looks like in the web client. Also, I specify the confirm $false here. What I've just noticed with the get command is that I've accidentally chose the slower E1000E card as the card type in my template. With the set command, we can change this to the VMXNAT3 type. Of course, it's better to select the right type when creating the template. Then we start the VM and open the console so that we can see what's happening. As you can see, I was too slow. The VM is already started. The login with the password we specified in the customization spec does not work yet. Instead, we have to wait until the VM restarts itself. This usually happens after 2 to 30 seconds. During this time, all the things we specified in the OS customization specification are processed. As you can see, a lot of things happen here, and all of a sudden we are automatically logged in as the local admin. That was the checkbox we set. Since we set the value to 2, the same will happen at the next reboot. After that, we will be asked for the password, like usual. Let's see. Setting the static IP worked. The time zone is also correct. The computer name has already been changed and the server was added to the domain. A sysprep was also performed. Of course, you don't have to execute the script line by line as I just did. Instead, you can simply select everything with Ctrl A and then execute it at once. For this, I create a new VM. Of course, we should assign another name and another IP address. Excellent. The PowerCLI is a very helpful tool to keep the VMware tools always up to date. Compared to clicking through the VMware tool setup manually, you can save a lot of time here. To be honest, during the first installation, the PowerCLI is not so helpful. We can mount the installer with mount tools, but then we have to click through the setup manually. Instead, I recommend you to install the VMware tools on the template. If you want to use the OS customization feature from the last video, you have to do so anyway. Alright, so we have that problem out of the way. Alright, how can we get an overview of the VMware tools in our vSphere environment? First, we query a VM and store it in a variable. Let's run getMember and see what results we get. Each property we see here can contain one or multiple properties. Specifically, I'm talking about the attribute extension data. First, we try to retrieve its content with select object. The output is not very helpful. This is because extension data is a nested property. Here, we can jump one level deeper with the dot operator. So we type $vm.extensionData and get more information, or better said, more properties. Some properties we see here are also nested. For example, config. As you can see, there are tons of information about each VM. To find information about VMware tools, we have to navigate to the property guest. Here, we are interested in the two properties tools version, which contains the version of the VMware tools, and the tools version status. The latter indicates which tools need an upgrade and which are up to date. In addition, we can see when no VMware tools are installed on a VM. So now we query all VMs again and select the name of the VM as well as the two attributes I've just mentioned. Now we need a feature that we haven't used before. Since we cannot simply specify a nested property, we have to create a so-called custom attribute. Instead of the property's name, we specify a hash table. This is what the basic structure looks like. To be honest, the syntax of this hash table might be a bit strange at first, but you can simply save it as a template somewhere and then copy and paste it when needed. As for the name, I recommend you to use the actual name of the property. As the expression, we specify the nested path, so extension data.guest.tools version. In the second hash table, we then use the attribute tools version status. This is what the query looks like now. Using tools version status, we can now see if VMware tools are installed and whether they are up to date or require an update. So far so good. We will go into more detail about the custom attribute when we create the HTML report. Assuming we want to upgrade the VMware tools of a virtual machine, we query the VM with getVM and pipe it to the command update tools. Within usually 1 to 2 minutes, the tools are then updated. By default, PowerCLI will also perform a reboot of the VM. If you prefer to manually restart the VM after the upgrade, you need to specify the parameter no reboot. This error message appears because the VM is powered off. In this state, the tools cannot be updated, of course. We will upgrade the VMware Tools later. First, I want to make some adjustments to our query. Specifically, I want to only get the VMs that need an upgrade, so I set a filter with rare object. Also, I'm only interested in the VMs that are currently powered on. Then, we connect the two filters with an AND, since we only want to get VMs where both conditions are met. Now, I start the second VM so we have multiple objects. To upgrade all virtual machines that this query returns, we need a for each loop again. As I said, the variable names don't matter at all. I'll just use the variable names from the snippet. Here, we call the update tools commandlet in each run of the loop, so for each virtual machine and $collection. The first variable always contains the current object, meaning this line in the first run and this one in the second run. But we are only interested in the name, so $item.name. I also like to use the parameter verbose here, because otherwise the commandlet would only provide us with feedback in case of an error. In yellow, we can see the output of verbose. If we run the get command again, we shouldn't get any results. And indeed, we get no results. In the query with all VMs, we see that the tools version status was changed to guest tools current. Excellent, that's what we wanted. Sometimes it can be helpful to export data from PowerShell. The simplest method is the export as a CSV, i.e. as a comma-separated file. The appropriate commandlet is export CSV. We call the commandlet after a pipeline through which we pass the data we want to export. Here's an example. We first call the getVM command and then pass the data to export CSV. Of course, we could also use several pipelines in a row here. For example, we can use select object to display other attributes in between. Everything we can see on the screen will be included in the CSV file. As with the import CSV commandlet, there are actually three useful parameters. First, the path, then the delimiter, for example the semicolon, and then the encoding. The latter is not mandatory, but I would recommend you using UTF-8 in most languages. If you use a version older than PowerShell 6, a so-called type header will be attached to the CSV file by default. I show you an example of it on the screen. If you don't want the header, you can specify the parameter no type information. Starting with PowerShell 6, the type header is not attached by default, which is great in my opinion. In the next chapter, you will learn how to export an HTML file instead of a CSV file. This gives us a lot more opportunities. Welcome back to the course. Similar to the last lesson, I will talk about exporting data, but this time as an HTML file. This is what the report looks like that we will create step by step over the course of the next couple of videos. As you can see, we will find old snapshots, for example, or VMs with an old version of VMware Tools. What I want to say right from the start is, there are already vCenter monitoring tools out there that offer even more features than we will implement. But why do we create the report then? And the answer is, it's a very good exercise for you and you will definitely learn something. And B, again, the course is not designed to teach you about every single commandlet out there. Instead, you will learn some basic principles that you can adapt to each and every commandlet. And you will definitely learn a couple of those basic frameworks in the next videos. So stay tuned for what is coming. By the way, the commandlets we use to create the HTML report are not PowerCLI specific, so you can use the same PowerShell, HTML and CSS code to create reports for the Active Directory, for instance. Whenever I create long scripts, I create so-called regions. Regions are a feature that help you to structure your code and make it more clear. You combine code that belongs together in one region. The region is simply introduced with the keyword region. After that, we assign a name, for example, region connecting to vCenter. We can mark the end of a region in the same way. The only difference is that we use the keyword end region. The convenient thing is that we can now collapse the region. If we open a long script without any regions, we see thousands of lines of code and may not be able to tell what the script does at the first glance. In a script with regions, however, we can immediately understand what the script does and what happens in which part of the script. If we want to adjust something, we simply expand the appropriate region and edit it. As you already know, we always start by establishing a connection to a vCenter server. So we need the connect VI server commandlet again, which we provide with the name or the IP address of the vCenter. Because I want to use the vCenter server name later in the heading of the report, I store it in a variable which we can use for both the connect VI server commandlet and the heading. For those of you who don't know HTML, I'll briefly explain some basics. But don't worry, we only need some really basic things. Those of you who already know the basics can jump straight into the next video. When you learn HTML, you will often hear the word tag. Everything that is displayed on an HTML website is placed inside so-called tags. So if you want to display an image, for example, or a headline, or just a normal text block, you always need a tag. The type of tag is specified between angle brackets. The tag is opened here and closed here, so be aware that the closing tag always contains a slash. For the browser to even know that it is a website, we first need an HTML tag. Altogether, the website consists of two parts, the head and the body. The head contains technical information that the browser does not display directly, for example, the title of the website and other browser information. The body in turn contains the tags that we can see, for example, the headings. CSS is the abbreviation of cascading style sheets. It's the code that is responsible for the appearance of the website. So we could use it, for example, to set the text color and the font size. Later, we want to hand over the CSS code to the commandlet that creates the HTML file. Therefore, we save it in a variable. Since we are going to write several lines of CSS code, we use a hash table. Because the CSS code is by definition located in the style tag, we create an opening and closing style tag. The CSS code is divided into so-called rule sets. A rule set always starts with a selector. This is the name of the HTML element we want to apply the design to. For example, the CSS code should be applied to all p tags. What happens in the p tags is specified between the braces. For instance, we can change the color of the text with the color property. After a colon, we specify the value, for example red. Additionally, we can set the font size to, let's say, 15 pixels. Within a rule set, the individual declarations are separated by semicolons. Let's get to the actual code we use for our report. I'll just walk through it and explain what happens. Since this is a PowerShell and not a CSS course, you don't have to reinvent the wheel. Instead, you can simply go ahead and download the source code below. These three declarations apply to the entire body, meaning to everything that is displayed on the website. So I want to have this background color, this font, and this font size. I want the H1 headings to have this color and be centered. I also specify display block here. This makes the heading a block element that takes up the whole line. To make it more clear, I put some examples for the display property on the screen. Furthermore, I want the H2 headings to be black too. TH is the abbreviation of table header. I want the text in the table header cells to be white. Additionally, I want this background color. Also, they should be bold. Next we have TD, which stands for table data and therefore addresses the remaining normal cells in the table. Here I want to set this background color. I want the table to have shared borders. The example on the screen would be the alternative. In addition, the table should use the full width of the screen, or better said, the full width of the browser window. If you want to address multiple selectors, we can simply separate them by a comma. So in this case, we address each table element. With border, we specify the type of border around each cell. I want my border to be 3 pixels wide, solid and black. An alternative to a solid line would be a dashed line, for instance. Then I want to add a padding to each cell so that the text does not start directly at the border, but is instead 5 pixels away from it. Again, I'll show you an example on the screen. In this video, we will start to add data to our report. In particular, we want to have an overview of snapshots that are older than a specific number of days. We already talked about that in one of the previous videos. If you haven't seen it, I'd suggest you to go back and watch it before. For everybody else, I'd suggest you to pause the video and see it as an exercise to check your knowledge. So pause the video and query every snapshot in your environment that is older than, let's say, 3 days. Ready? Here's the solution. First of all, you need a variable that contains the date. So you need the commandlet getDate. Remember, you have two options here. The first option is to use the parameters day, month, year, and so on. However, I would not recommend using this method in this case, because the end goal is that the script runs automatically every day and sends you the result as an email. So the problem with this option is you will need to change the date manually every single day. The other method, and that's the one I recommend by the way, is calling the method addDays. Perfect, now we have the date stored in the variable $timestamp. The next step is to query all virtual machines and their snapshots. We only want snapshots older than the date in $timestamp. I used the comparison operator lower than, but you could also use lower or equal. There's only 1 second difference in this case, so it doesn't matter. Perfect, we've completed the task. However, I don't want to have the 3 default properties in my HTML report. Instead, I'd like the name of the VM, the name of the snapshot, the description of the snapshot, the creation date, and the size of the snapshot in gigabytes. Excellent. The only problem is that we still have a PowerShell object, but we want an HTML object. Therefore, we send the output over the pipeline to the commandlet convert to HTML, which creates fully functional HTML code. If you know HTML, you've probably already recognized the table tag, which simply marks the beginning of a table. With the parameter pre-content, we can add HTML code before the table. In this case, I'd like to add a heading. For that, we can use the text h1 to h6. The smaller the number, the smaller the heading. Perfect, here's our heading. Time to create a new region. In this one, we want to concatenate the snapshot table from this video with all the tables we will create in the next videos and export them as an HTML file. The commandlet we need for that is again convert to HTML. Here we use the parameter body to hand over the HTML code we just created. Of course, we use a variable to do so. Furthermore, I want the HTML report to have a big h1 heading, which I also store in a variable. Besides the words vCenter check, I want my heading to contain the IP or the name of the vCenter. Good that we stored it in a variable in the connecting to vCenter region. To ensure that our CSS code is taken into account when creating the HTML file, we include it with the parameter head. We don't want to have the output on the screen. Instead, we want to create an HTML file and save it in a directory. We can do so with the commandlet out file. The file that is then created can be opened with a browser of your choice. Perfect, here we can see the H1 heading, the H2 heading, and the table. As you can see, for example by the yellow background color, our CSS code was also taken into account. We should also consider what happens when the query returns no results. Let's simulate this by querying snapshots that are older than 300 days. I don't have any of those in my vCenter. In this case, the H2 heading will be displayed, but the table is missing, of course. Instead of the table, I want to display a simple sentence saying that there are no snapshots older than X days. To do so, I rename the variable and remove the part where the HTML code is created. The reason for that is we want to create the HTML code only if getSnapshot returns results. For that, we need an if statement. To create one, we can simply use the if snippet. In the condition, we want to check if the variable $snapshots contains data or not. There's a straightforward way to do so. We simply enter the name of the variable. Here, I create a new variable called $HTML_snapshots. Its value is $snapshots as an HTML object. For that, we can simply use the code we just copied to the clipboard. So what happens here in particular is, if the variable $snapshots contains a value, i.e. if there are snapshots that match these conditions, the HTML code is created and stored in the variable $HTML_snapshots. In case the variable is empty, aka no snapshots match the conditions, we need an else block. Here, I still want to display the H2 heading, this time followed by a normal text paragraph saying that there are no snapshots older than 3 days. This is how the report looks now. Of course, I'm going to change the 300 days back into 3 days. Now we have the basic structure we can use for all other tables, which we are going to create over the course of the next videos. In this video, we are trying to find virtual machines that have an ISO file mounted to the CD drive. Additionally, I'm going to show you how you can unmount all of them with one single line of code. But first of all, we need to create a variable similar to $snapshots from the last video. To find mounted ISO files, we first query all VMs that are powered on. Next, we send them over the pipeline to the commandlet get CD drive. Then we need select object in combination with the wildcard to have a look at all properties. Only 2 of them are actually useful. Those are parent, aka the name of the virtual machine, and the ISO path. If the latter is empty, no ISO file is mounted. Therefore, we are only interested in the VMs where the ISO path is not empty. The where object filter for that looks like the following. $under.isopath not equal $null. Excellent. Now we can simply copy and paste the basic structure that we prepared in the last video. The only thing we need to change are some variable names and the text. One thing we shouldn't forget is to add the variable $HTML ISOs to the HTML report that will be exported. By the way, if you want to unmount all mounted ISO files, simply take the command as it is and remove the ISO files by using the set CD drive commandlet and the parameter no media. This is the perfect opportunity to test if our if-else statement worked. Great, because we just unmounted all ISO files, the else block is being executed. Time to create a new region. Particularly, we want to add data stores to the report that have less than 20% free space remaining. You've already learned about the get data store commandlet. Let's have a look at the available properties. Two interesting properties are the capacity and the free space of the data store. However, we are also interested in the free space in %. Unfortunately, there is no built-in property for that. Instead, we have to create a custom attribute. You've already learned about them in the video where I talked about VMware Tools. Again, this is the basic structure that you hopefully saved somewhere to be able to copy and paste it now. First, we give the custom attribute a name, for instance, my capacity in MB. In the expression, I type the name of an existing property, for example, capacity GB. So far so good. We created our own property, however, with the value of the capacity GB property. Now it's getting interesting, because we will use so-called calculated properties. As an example, we can convert megabytes into gigabytes. To do so, we simply need to multiply the capacity in gigabytes by 1024. Okay, back to our problem. We want to know the free space of each data store in %. I want to use the name free space in %. If you've spent attention to the math classes back at school, you would know that you get the free space in % by dividing the free space through the total capacity and multiplying the result by 100. So far so good. However, I don't really care about the many decimal points. Fortunately, there's a function called round. In PowerShell, we can call math function by using the following syntax. And by the way, you also don't have to remember the syntax. Simply save it somewhere and you're good to go. Alright, back to the round method. We use the double colon in this case because we're calling a static method. Now we are able to scroll through the list of mathematical functions. The one we're searching for is called round. The method expects two numbers. With the first one, we specify the number we want to work with. For instance, 123.4567890. The second number specifies the number of decimal points to which we want to round the first number to. For example, 1. This is how it looks like with 3 decimal points. Alright, now let's add the round method to our existing commandlet. I personally want to round the number to 1 decimal point. One property I also want to include in the report is the free space in gigabytes. Oh, at this point I forgot to put a comma between the property names. Sometimes it's a bit chaotic when we use the backtick in the middle of a command, like I do here. Pretending we have multiple thousand data stores, the last thing we want is to read the name of each and every data stores in the report every morning. Instead, we only want to include the data stores with less than 20% remaining capacity. So let's use whereObject to only select those data stores. Next, we insert our basic structure from one of the previous regions and change the name of the variables accordingly. Last but not least, we add the variable $HTML data stores to the final report. Let's see how it looks like. As you can see, the free space also has many decimal points, so let's round it to 1 decimal point too. We can simply use the same syntax. It's an excellent exercise to add some general facts about the vCenter we're connected to. And this is because, in this case, we don't have one universal commandlet that returns the information we want to know. Instead, we have to create the table, or better said the object ourselves. The easiest way is to use a so-called PSCustom object. Again, you don't need to remember the syntax, just save the code as a template somewhere and then copy and paste it if needed. This is what the basic structure of the PSCustom object looks like. In this block, we start by defining the table headers, so to say. I want to query the amount of VMs, the powered off VMs, the amount of hosts, clusters, and data stores. Since powered off VMs are actually 2 words, we have to use the quotation marks here. You already know that we can query the VMs with getVM, but how can we count them? It's actually really easy. We simply use the count operator. The syntax looks like the following. First, we put the query in round brackets. After that, we put a dot followed by count. This counts the objects returned by getVM. We can use the same structure to count the powered off VMs. Additionally, we have to use whereObject to only select the VMs that are actually switched off. Be careful when querying the number of hosts. There's a commandlet called getHost. However, it provides us with information about the system, such as the PowerShell version. The PowerCLI commandlet we're searching for is called getVMHost. Alright, I think you understood the underlying framework. Also, you already learned about the commandlets getTemplate, getCluster, and getDataStore. Last but not least, we convert the PSCustom object into an HTML object. Also, don't forget to add the variable to the report. This is what the report looks like now. One thing I would like to improve is the following. We don't get any feedback during the execution of our, meanwhile relatively long script. Therefore, I'd like to make an output on the console at the beginning of each region. The appropriate commandlet is called write_host. Two parameters are relevant here. One is the color of the text, and the other one is the object, i.e. the text you want to display on the screen. For example, in the data store region, I would write loading data stores to the console. I can then copy the line and paste it into the other regions. If there's an error, for example while querying the snapshots, the red error message would appear between this line and this line. Therefore, we would immediately know that it has to be an error in the snapshot region. We have already discussed in detail how to query the status and version of VMware Tools. That's why I want to keep this video very short. The two tools version statuses that are interesting for the report are guest tools not installed and guest tools need upgrade. So all VMs on which VMware Tools are not installed and VMs on which VMware Tools are installed but need an upgrade. So let's query only these two statuses with where object. We connect the two filters with an OR, since only one of the two conditions can be met at a time. To improve the readability of the script, I used a little backtick character to split the command into multiple lines. Now we've successfully selected these two properties. In addition, I would like to add the property PowerState to the report. That's it. Now let's save the whole thing in a variable and convert the PowerShell object with the help of our template into an HTML object. We also copy the line of code where we make the output on the screen. Excellent, that's how the report looks now. Now we are going to improve some things. One thing we've talked about in one of the first videos is that we should disconnect from the vCenter once we've finished our work. So we can simply copy this region and adjust it accordingly. We already defined this variable, so we don't need to do it again. The command that is called disconnect VI server, so we only have to replace the verb connect with disconnect. We should also specify the confirm $false again, otherwise we will be asked for confirmation every time. So far so good. Additionally, I would like to append the creation date at the end of the report. We can do so with the parameter post content, which we hand over another paragraph tag. For the creation date itself, we need a new variable, for example with the name created on. Here's the result. One thing that bothers me a little bit is that I always have to change the file name manually. Instead of v1, v2 and so on, we could just add the current date to the file name. You already know getDate. What's probably new for you is that we can format the date with the method toString. Because I'm not interested in including the minutes, hours and seconds in the file name, I only enter the year in a 4-digit format, followed by the month and the day, both obviously in 2-digit format. We should not put any dots in between, because they usually introduce the file extension. If you want to, you can use hyphens instead. Let's see if that worked. And indeed, the file name now contains the current date in the format we specified. The next step is to send the report by email. Until a few years ago, it was very easy with a built-in PowerShell tool, namely with the commandlet send mail message. If I execute the commandlet, a message from Microsoft appears saying that the commandlet is outdated and should therefore not be used anymore. This is because Microsoft doesn't support many modern protocols anymore. Unfortunately, there is no replacement directly from Microsoft available. An alternative is Send MailKit Message. This module uses the MailKit library recommended by Microsoft. First, we have to install the module with install module. As with installing the PowerCLI module, we can choose between installing the module for the current user or for all users. For the latter, it is necessary to start the PowerShell with administrative rights. With the letter Y, we confirm that we are sure that we want to install the module. I already prepared some code. If your SMTP server requires authentication, we have to provide the credentials somehow. I created the variable $credentials and used the commandlet getCredential to store them in there. Okay, let's talk about the actual send MailKit message commandlet. I specified some parameters. Among them are the SMTP server, the port over which the mail should be sent, the sender address, the recipient address, the body of the mail, the subject, and our attachment. By the way, here you can simply copy the path from the export to HTML commandlet. Then we provide the credentials and tell the commandlet that we prefer a secure connection. Alright, time to run the script and see if we get an email. But before that, we should remove the install module code, because we have to install the module only once. I'm going to show you how you can save the credentials in the next video, so you don't have to type them every single time. I've already opened my Outlook in the background. And indeed, here is the mail with the HTML report as an attachment. As I mentioned in the last video, it's pretty annoying that we have to enter our login credentials every single time. That's why I'm going to show you how you can save your credentials. First of all, we need the getCredential commandlet, which prompts for the login details and creates a credential object with the username and password we provided with. We then pipe the output into the export CLI XML commandlet. This stores the PS credential object encrypted on the file system. For that, we have to specify a path where we want to save the XML file. let's have a look at the XML file. The username is not encrypted and therefore readable. This is normal so far. The password, however, is encrypted and therefore not readable by humans. Before we get to the technical background, I want to show you how you can import the credentials from the XML file into the PowerShell session. And of course, we don't want to import them into nowhere, but into a variable. For instance, $credentials. The import itself is possible with the commandlet import CLI XML. Here we have to specify the path again. By the way, we only need to run the export commandlet once. Therefore, we can delete or comment out this line of code. In my case, send mailkit message already expect the variable $credentials, so I don't have to change anything here. Finally, we can delete this line of code. I also want to store the vCenter credentials encrypted in an XML file. The same principles apply here. We import the XML file with import CLI XML into a variable. Then we need to hand over the variable to the connect VI server commandlet. Alright, let's get to the technical background. The export CLI XML commandlet uses the Windows Data Protection API. The key used for the encryption is the Windows account under which we run the export CLI XML commandlet. That means that you can use the credential file only on the same computer with the same Windows account. On another computer, even if you're using the same Windows account, the XML file is not readable and therefore worthless. By linking the XML file with the Windows account, there is also a disadvantage you should be aware of. If someone has access to your Windows account, he can decrypt the password. I can show you how. You actually already have the necessary knowledge. So we use getMember to query the compatible methods. After some trial and error, you will use the method getNetworkCredential. You don't have the password yet, but if you execute the getMember command again, you will find the attribute password. And then you have the password in plain text. But like I said, this is only possible on the same computer with the same Windows account. Let's see if our script works. Since the mail arrived, it means that the credentials for the SMTP server were correct. And since the report contains data, it means that the login to the vCenter was also successful. Now we're ready for the next step, the automatic daily execution. Of course, we don't want to sit in front of our screen every single day and execute the script manually. Instead, we assign this task to the Windows Task Scheduler. It is built into the Windows operating system and allows us to schedule the execution of various tasks, including the execution of PowerShell scripts. You can find the task scheduler by typing task scheduler into the Windows search. Alternatively, you can open the task scheduler from the run window with the command displayed on the screen. I recommend you to use a Windows server that is always running anyway, because if you shut down the system, the task won't get executed obviously. Alright, here we simply right-click a free area and click on Create New Task. The first step is to give the task a name and if you want a description. If you want to run the task as a different user, you can specify the other user account here. But be aware that in this case, you have to create the CLI XML files also with this user. Next we select Run whether user is logged on or not. Otherwise the task would only be executed if the user is currently logged on. Finally, we select Run with highest privilege. In the Trigger tab, we define when we would like to run the script. I would like to execute the task daily at 9 AM. In the Actions tab, we click New and then choose Start a Program. To find out the right path to the PowerShell executable, we simply type PowerShell into the Start menu. Then we right-click the PowerShell console and select Open File Location. Make sure you choose the right console. So if you've installed the PowerCLI module in PowerShell 7, you have to select PowerShell 7 here. If you have used Windows PowerShell, you have to select Windows PowerShell. In the Explorer window that appears, we only get another shortcut. So we right-click it and select Open File Location one more time. Now we have the executable file and can copy the path to it. By the way, the Windows PowerShell executable is called PowerShell. The one for PowerShell 7 is called PWSH. One thing we haven't talked about yet is that the PowerShell has a so-called execution policy. The main purpose of the execution policy is to prevent the accidental execution of untrustworthy scripts. One possibility would be to use the set execution policy commandlet to set the execution policy to unrestricted. Alternatively, we can leave the execution policy protection active and instead add the parameter execution policy with the value bypassed to the task scheduler. This simply bypasses the execution policy. Another parameter we need to add is file. It expects the path to the PS1 file. We don't really need to pay attention to the two tabs Conditions and Settings. The only exception is if you're working on a laptop, because by default the task is not being executed when you're in battery mode. So if you don't like these settings, simply remove this checkmark. After clicking the OK button, we need to type our password. Since I don't want to wait until 9 AM tomorrow to see if our task works, I just right-click the task and choose Run. This executes the task immediately. There we go, here is our email.